Hello, we are team number 5 of Petronas Twin Tower, and I'm the presenter, Shinmin-won. Last week, we have looked into the vertical structural features and the pinnacle. Today, we are going to look into the sky bridge and its support of the building. First, let me introduce a brief description of the sky bridge. Why do we need sky bridge in building? Sky bridge is the bridge that links two respective buildings, mostly in high-rise building. Due to its design feature of sky bridge, the building itself can be the landmark of certain region. Also, when we stand on the sky bridge, we feel like we are above the sky, having unusual experience. In effect, the sky bridge of Petronas Tower is mainly used for sightseeing and popular for many tourists. Sky bridge also has other structural features like providing traffic line and resisting to earthquake and lateral wind forces. Now, we'll look for the structural features. The first model sky bridge support was made of upper part, which is cable supported, and lower part supported by structural element used in cat's cradle. This support structure remind of spider web, which had strength in stability because the bridge was supported by steel wire. But it had serious problem of cut-off wire when the entire building is shaken by earthquake or lateral wind force. After several research were considered, the arch form support was finally selected. It was not just the arch formation of intersecting truss, but they used thin long-span girder instead. The sky bridge support was made of 1.1 meter diameter steel pipe. It is lifted up from the lower part of each building in diagonal direction and meets under the center of sky bridge. It makes the tilting of bridge at minimum made by the lateral movement of building. Now, we will look into the construction features. The bridge and support was made in Korea and was mainly assembled in the ground level. It is installed in 41st and 42nd floor of each building by lifting the bridge and the support with jack-up system. This sky bridge had significance in interlocking two towers from Hajima Construction from Japan and Samsung C&T from Korea. Then, let's look into the process of constructing the sky bridge. Sky bridge is the structure mainly in the high-rise building. So it has tricky construction process and must be examined closely. The very small mistake or miscalculation could even lead to collapse. Then, how was this sky bridge built? Due to its enormous weight and size of the bridge, they chose to apply lift-up method. It is the method using hydraulic system. The main advantage of using lift-up method is safety. There can be high risk when constructing structure directly in the high heights, but lift-up method constructs structure in the ground level, which is relatively safer. Let's look into the lift-up method construction by short video. First, we install temporary structure. The temporary structure have to be constructed thoroughly because it has to resist load when lifting up the bridge. When temporary structure is installed, we make the sky bridge by welding steel frame and assembling. When the sky bridge is made, we install the lifting equipment in upper part. There must be close examination in the equipment location to prevent accidents. So we double-check the construction location by laser to raise precision. We have to calculate the vertical and lateral force and reinforcement in advance, because there can be distortion by very little difference of force while lifting. Distortion and deflection is easily occurred, especially for the vertical loads, so there must be reinforcement in advance. After locating the bridge in precise location, we install floor and window and framework. The final process of construction is lifting up. The bridge is lifted up to 177 meters with the force balanced status and connected to the upper part. Since the construction is proceeding 177 meter height, the safety is mainly considered. The construction is finally completed by connection of the bridge. The engineering of the sky bridge, critical to Pele's design intent, was recognized as a significant challenge. Preliminary hopes that the bridge might actually be used to help stiffen the two towers were quickly abandoned, and the difficult problem of separating the bridge from the differential movement of the towers was addressed. Expansion joints, located at both ends of the bridge structure, were designed to isolate the motion of the two towers from the bridge. The addition of four 3.6 feet diameter wishbone legs, although not needed to support the midspan, helped to minimize deflection and maintain the centering of the bridge structure. Lateral wind loading on the bridge itself had to be studied as well. Tuned mass dampers were designed to be installed in the wishbone legs to alleviate vibrations resulting from vortex shedding associated with the lateral wind loads. To summarize, the sky bridge of Petronas Twin Towers are composed of double-story height, main girder, the box girder, and the spherical bearing, the knuckle, and the support point on 29th level of the tower. Today, we have looked into the sky bridge of Petronas Twin Towers due to its several important features. These are our references, and thank you for listening.